Okay, so yesterday, so we saw right installation about six, right? Now we'll see the operating system architecture once again, and then we'll see the booting process. Hardware to install for to use any operating system required hardware. So based on requirement, so we have to buy the hardware. So for home purpose, there is a different configuration for to host any application or to run any database services on top of any operating system. So based on that, we have to choose a hardware configuration. See here, hardware configuration is nothing but like CPU, RAM, okay, storage and network interfaces, okay, so RAID controllers, that means depends on, okay. So CPU, we have different CPUs types like Intel, Xeon, AMD CPUs. So in Intel also there are different versions, i3, i5, i7, okay. See, every process comes with a different speeds also. So 1.7 gigahertz and 2.0, 3.5, and every processor comes with along with speed. There is a cache memory, 2 MB, 4 MB, 8 MB, 16 MB. So depends on MB processor cache memory, you will get a high performance. So for normally when you buy a laptop or a desktop, so it comes with at least 3 MB cache memory nowadays, and in the past 2 MB. Okay, see, and RAM also. So there is a difference between so you whatever the RAM desktops and laptops we are using, so that RAM and the server side also, okay. So it comes with a robust speed when you compare with your normal RAM, okay. Like storage also. So for when you buy a laptop, so your storage comes with a different speed. When you buy a server for to host application, that storage comes with a different speed, okay. And cost also is effective. So depends on network also, network interface cards. See the bandwidth. So 1 gig, 2 gig, 3 gig interfaces are available for home purpose. So basically nowadays comes 1 gig Ethernet cards for every laptop and desktop, right? See, we have to choose this. So it depends on your application. Say whatever the application you want to host. So based on that, we have to choose this configuration. See, we have different vendors, right? Dell, HP, Lenovo. There are different vendors for that, so we can choose the hardware. But the Dell is the most compatible hardware for your Red Hat and Linux. Compatible hardware. So Dell. See, who will take care about these things? So which configuration we want to buy? So which operating systems we have to install? So there is a IT architect team in environment. Okay, so IT architect team. See, before going to get the project, see if the BDMs will interact with the client. So they'll collect the requirements, client requirements. So once get approved, see at final talk, your IT architect team will design the phase, the process, first staging to end process, the completion. See how much time it takes to complete the project. So manpower required, like development team, testing team. So is there a database team required, storage team for to manage that services, so to provide a service for a particular project. See, along with that, hardware also they'll decide. For see, operating system they'll choose, and technology also. So we have a different server-side scripting languages like Java, .NET, PHP, Python, Ruby. So there are web applications, right? So we can build web applications using these server-side scripting languages. See, depends on client interest. So we have to choose this, and the same thing. For example, want to build application in Java. Operating system technology is ready now. So based on this and the project, Okay, see the client expectations. We have to choose the hardware also. Have to choose the hardware also, right? See, once get approved, so one document will be forwarded to every team. So for there is a teams like UI designers, user interface designers. That means Photoshop web designers. Okay, so they'll design the first the body of the web application, the front end, the view, home page need to like this, inner pages need to like this, user profile page like this, okay, and subscription page like this, login page like this. So first they'll design. So once get approved, okay, so then the same pages will be forwarded to development team. So parallelly, so there is a database team. So as per documentation, your application documentation, so they will design a database structure, skeleton. First they will build a skeleton. Okay. So for that we have to install database also, right? So here we have a databases like Oracle, MySQL, MongoDB, MS SQL Server, DB2. Like there are different database softwares are available, but the most popular one is Oracle. So then MS SQL, MySQL. So MySQL is a open source. MongoDB also is open source with free of cost. We can download and can use it. So if you want services, Oracle, you have to buy a license. MS SQL Server also, and DB2 also. DB2 is a IBM database. IBM database. So this is also depends on client requirement. Okay. See, we have to install this. Once the database team so design that skeleton part. See, both are ready, right? The same thing is forwarded to your dev team, development team. Then write a code to insert data into database to get data from the database. For that, so they write some code using the scripting languages, server side scripting languages. So based on the requirement, we have to choose the hardware. Okay, so once get, then install operating system. So your operating systems, we have Windows Server, Linux servers. So in Linux, there are different servers and vendors are there. So Red Hat, CentOS, Fedora, Ubuntu, Debian, SUSE, Mandrake, Kali Linux. There are different Linux operating systems are there, but the most reliable, fast, and secure operating system is Red Hat and Linux. Okay, and CentOS, Ubuntu. Right? See, once you install operating system, see, the operating system comes with a structure, kernel, and kernel on top of shell. So user interface, user space. When you power on the machine, so you'll get a console. Enter username and password. Once you enter username and password, so during that process, your shell process will read, it loads some configuration. So what is it configuration? Basic environment for user to manage services, to run applications, to execute some commands. The shell will provide that environment. Because the user directly can't communicate with binaries, right? Your operating system comes with a set of programs. Programs is nothing but a binaries, executables. They can read that. So for that, require a interpreter. So your shell will act like that. So here, the default shell is bash. Bash is the default shell environment, and we have a C shell, K shell. Like there are different shells are available. We can use it. Right? See, it comes with hundreds of system calls. Like when you run a command, there are different system calls to start a new process, to execute a process, to wait, to exit. Like we have a system calls like fork, okay, wait system calls, and exit system calls. So when you run a command, date. So once you run, shell takes that request, it processes to kernel. Your process will search for the related function inside that kernel space. Is there any function related to date? It will execute, it shows the desired result. If there is no function related to that, it throws error message like no command not found, sorry, command not found. Sometimes when you're trying to access a file, if the file already exists, it shows the output. If there is no file, it throws no such file or directory like messages. For every command, for every instruction, there is a specific function under kernel level. So kernel will do that job. Okay, it takes a request and it converts, it processes again. Okay, so major functionalities of kernel is like memory management, disk management, process management, IO management, file management, job schedulers. So when it required more memory for a particular process, automatically it will allocate. Okay, when you start a new process, it allocates memory resources, CPU resources, and storage resources. For every new process or running process required a CPU resources, memory resources, and storage resources. These three are important. So automatically your kernel will allocate this. So kernel is nothing but operating system. Your operating system will allocate these resources. Okay. See, we can start a process with different priority also. So we can modify existing process priority also. So there are, we have a commands. So using those, we can change the process priority. So we'll see that in process management. Okay. So now we'll see the booting process. Now we'll see the booting process of your operating system. See, so when power on the machine, so there is a settings like BIOS. It comes with your hardware, right? So there is a BIOS settings. So when you enter into the BIOS, we can modify the parameters. So as per our requirement, we can change, we can set the default settings there. Okay. See, when you power on the machine, BIOS wake ups basic input output system. It performs post power on self test. Power on self test. So it's a self test in the sense it checks all the hardware peripheral devices it's functioning properly or not. So once it's done that step, then it will search for a bootable device. Then it will search for a bootable device. So what is bootable device is nothing but here. So where the operating system is installed. Searching for the operating system installed storage. So here the bootable device might be like CD or DVD, USB, storage, HDD, or any external storages, any devices. We can boot from CD or DVD or USB or storage or any external devices. We can boot. Once it finds, then it will execute MBR. It executes MBR. So MBR stands for Master Boot Records. So it contains first sector of the bootable device. It contains at first sector of the bootable device. So MBR size is 512 bytes. 512 byte size. Okay. So it contains a partition table information, and bootloader information. So basically MBR contains three partitions like 446, right? 512 bytes. See, 446, it contains bootloader information, and this one it contains partition table, and it contains integrity check. These 2 bytes is used for integrity check. The 512 bytes, 446, it contains the bootloader information. The remaining 64 bytes it contains partition table. That means how many partitions are there on which partition the bootloader is available. That information it contains, and these 2 bytes is used for to check the MBR sectors. For integrity check, it utilizes the 2 bytes, right? So once it done, MBR executes bootloader. MBR executes bootloader. So here the bootloader name is grub. In Linux, the default bootloader name is grub. In Windows, NTLDR. NTLDR, network loader. In Windows, name is NTLDR. See, grub stands for Grand Unified Bootloader. Grub stands for Grand Unified Bootloader. So we have a version 2, latest version now. Grub 2 is the version in 7. Then your bootloader will execute. Grub stands for bootloader name. Grub is a bootloader name in Linux. Grub stands for Grand Unified Bootloader. See, bootloader is a small software program which loads operating system. That means it executes kernel. Kernel is core part of the operating system. It's like an operating system. It executes kernel. Right? So then a kernel will load all the device modules during that boot process. See, whatever the peripheral devices are there, so related to that peripheral devices, related drivers will be loaded, and then it will mount the file system as read only first, then it will mount the file system as read write. There are certain processes. Okay, see, your kernel starts a new process named systemd. Grub executes kernel starts a process, very first process at user space, name is systemd in 7. Systemd is a very first process in RHEL 7. In 6 the name is init. Init is a very first process in RHEL 6 and 5, process name. See, once get started the process, this process will initialize the run levels. So here we have a different run levels. So based on run level, some services will be started and some services will be stopped at boot time. Okay, the run level will decide. So which services need to start and which services need to stop. There is a related script files for each and every run level. Your systemd process will call that scripts. It executes the scripts. Once it executes the script based on the default run level name. Okay, so based on run level, services will be started. Run levels. So here also known as targets. Targets in RHEL 7. RHEL 7. Okay. Run levels 0 to 6 we have. Run level 0, 1, 3, 4, 5 and 6. These are all 6 run levels, 0 to 6 run levels. Say 0 is a halt. So run level 0 is halt. Sorry. Halt means shutdown. So your system process will execute if it executes first run level. It means 0. What it means? Your server goes down. Automatically all services will be stopped. See, run level 1, single user mode. Run level 1, single user mode, also known as rescue mode, without network services. Without network service. Single user mode. So without network. That means once you enter into this mode, single user mode, so in this mode only we can able to log in as root. We can't log in as any other user accounts. It allows us to log in as only one user account, and at the same time your machine will be disconnected from the network because all network related services will be stopped. So see, in this mode we can troubleshoot if something went wrong at file system end, bootloader end, and might be MBR gets corrupted, or when you forget password, we can recover once you enter into this mode, single user mode. Okay, we'll see in troubleshooting. So how to do that task. Okay, run level 2, multi-user multitasking without NFS. Multi-user multitasking without NFS, network file system service. So we can't configure network file system service at run level 2. Multi-user multitasking in the sense, so when you start operating system at run level 2, so n number of users can connect to the server simultaneously, so they can perform simultaneously multiple tasks. Run level 3, full multi-user multitasking without GUI. Without GUI. Multitasking without GUI. That means there is no graphical user interface here. So run level 4, not yet used. So this is using for R&D purpose or ND purpose, not yet used. Okay, that means not in use. Run level 5, full multi-user multitasking like run level 3 with GUI. With GUI, graphical user interface. That means desktop, or also known as X11. Run level 5 is a X11. Right. So run level 6 is a reboot. Reboot. Correct. See, these are all the run levels. See, whatever the default run level we specified in the configuration file. So based on that, the systemd process will read the target file. Once it reads whatever the run level you specified as a default one, then it executes related scripts. So based on run level, some services will be started and some services will be stopped. Okay. So basically we are using run level 3 or 5. Okay. So even in a server environment, most probably we have to start operating system at run level 3, not require any graphical user interface. Even though you installed with server with GUI, we have to start at run level 3. So when it required, we can switch from run level 3 to run level 5. With network support. So without network, here only single user mode for only troubleshooting purpose. See, when you trying to troubleshoot something, if someone is working on server, okay, again something went wrong, right? See, for that first we have to disconnect the server from the network. So for that, once you enter into the single user mode, automatically services will be stopped, network services, right? So these are all the run levels based on this. See, here we have a configuration file. So based on the configuration file, your systemd service will start the operating system at desired run level, and your grub also, sorry, MBR also, it executes bootloader, right? So there is a configuration file. Based on the configuration file, MBR executes the bootloader. See, so we have a configuration file name. Sorry. grub.cfg, grub.cfg in 7 RHEL7, grub.conf in RHEL6, the name. These files are located in the boot directory. So I'll show you the location. Okay, so these files contains bootloader information, and that means your operating system information, the partitions, your operating system, and bootloader type. So when you install multiple operating systems on same hardware, that means dual booting. Like so for example, when you install like Linux and Windows on both same machine, so Windows bootloader is NTLDR. Here grub. Both bootloader information it contains. There is a default bootloader name, like again primary and secondary bootloader. We can specify that. We can use primary bootloader as Linux or this one. That means when you power on the machine, so automatically whatever the primary bootloader you specified in this configuration file, that operating system will be loaded. If you want to use the next operating system and second operating system, we have to choose that operating system at boot menu. When power on the machine, you will get a boot menu, right? So there it shows bootloader 1, bootloader 2, the names. From there we can choose. First we have to install, no, not Linux, Windows. Okay, the Windows operating system can't recognize the kernel, Linux kernel. Okay, see, this configuration file will decide. So it contains that information. We'll see that. And here, run levels, right? There is a configuration file like in 6 init tab. The file is under /etc directory, /etc/init tab, initialization table. So we have a process, very first process in 6 init, right? So that process will initialize the run level. So whatever the run level name here specified, init process will execute that the run level related scripts. See the parameter like here in the file id, run level number, then init default. So here we have to specify run level number 3 or 5. If you specify run level 0 as a default one, what will happen? When power on the machine, yeah, it will on, automatically it goes down. When you power on, so it will on, automatically it goes down because we specified default run level as 0. If you specify run level as 6, default run level as 6, what will happen? It will keep on reboot. Right? So for that we have to use 3 or 5. Don't use default run levels as 0, 1, 2 and 6. Use 3 or 5 as default run levels. So when it required 0, if you want to shut down, then execute. If you want to reboot, then use run level 6. So if you want to troubleshoot something, then use run level 1. We can switch from one run level to another run level we can switch. So we have a command init. Using init we can switch from one run level to another run level. That means we can change for temporary but not default. For to specify default one as a run level, we have to edit the configuration file. In this configuration file only you have to specify. So this is in 6. So how to set the default run level? So I'll show you this configuration file, how to specify the value. In 7, the name is default.target. Default.target. So that means here run levels also known as targets in RHEL7. Okay, the names are like this. The target names: run level 0, 0.target. So there are some script files like run level 0.target, run level 1.target, run level 2.target, up to run level 6.target. The script files. See, these script files are created to a soft link for this default.target file. Default.target file. So I'll show you the location. The files are under which directory. Okay. Once it created a default target as run level 3 or 5, so your systemd process will initialize this. It will execute the default.target file. See, if it contains run level 3 as a default one, run level 3 related script files will be loaded. So based on that, services will be started. Right? So this is a booting process. Booting process of your machine. So BIOS, basic input output system, it performs post. So once it done that, it will search for the bootable device. Once it finds the bootable device, it executes MBR, which resides on first sector of the bootable device. The MBR size is 512 bytes. It contains partition table information, bootloader information, partition table and bootloader information. So then once it finds a bootloader, it executes bootloader. The default bootloader in Linux is grub. Grub stands for Grand Unified Bootloader. See, we can also the name is also known as Lilo also. Linux loader. We can call like this also. Lilo. Linux loader. Okay. So your bootloader will load the operating system then, and kernel. It executes kernel. So then your operating system will start a very first process at user space in 7 called systemd. So this process is a grandparent of all process. So very first process in the system, always PID is 1, process ID. Always process ID is 1. So this process, is a grandparent of all process. This process will start the remaining process, the services. Okay. That means based on your run level. Systemd will initialize the run level based on the default.target config file. Depends on run level. That means the run level target services will be started at boot time. Then you will get a login screen. One console. Enter username and password. Once you enter username and password, again one process will be started. Shell process. The shell process will be started. It provides an environment for user to perform tasks. See. When you install operating system on physical machine, so if you want to build the same structure on another hardware, so is it possible to clone that automatically? No. So it takes time to clone. But here in virtualization, so we can export the appliances, existing appliance. So once you export it, it creates a OVA file, .OVA file in VirtualBox. So whenever it required, we can import that. But whatever the partitions you created, how much RAM you allocated previously, you'll get the same settings. Even though you configured applications or you stored some data, you'll get with the same data. Okay. Instead of installing every time, for that, create one basic structure operating system. So I'll show you how to export that. Yeah. Open in terminal. So if you want to see files, so whatever the files under current working directory. So once again I'll explain, just understand now. So we have a ls command, so we can see the list of files under current working directory. So what is current working directory? I'll explain later. See here we have a structure like, so file system structure, you'll see that. So this directory contains boot required files. Boot required files. cd is the command to change directory. We'll see that again. See what it shows here: grub, grub2, bootloader related config files, and kernel related config files. So during the boot process, the bootloader will read all these files: VM Linux kernel related init ramfs files, and then based on this, see, so we have a grub.cfg, right? This is a file. It contains the bootloader, operating system information. So for that we have a commands like grub. It contains information like the default settings. So this is the operating system information from here, right? The location, storage, so where the operating system is installed, the root partition information. So everything it contains. So based on this configuration file, bootloader will execute. MBR will execute the bootloader. So based on this configuration, your bootloader also it executes operating system, the kernel. We'll see what is VA, CD, LS, all these things. Like in 6, there is a configuration file name called grub.conf, not CFG, grub.conf. CFG in the sense configuration file, conf in the sense configuration file, .conf. Okay. Second. Yeah. Open in terminal. See, contains same thing, right? Grub. It is a grub. Grub.conf. By default, it reads. See, timeout value, title, kernel, the partition. So where the operating system is installed, the device name, init ramfs image, right? So if you have a more than one operating system, it contains that operating system, bootloader information below. So we can use this one as a primary or this one as a primary, like. Fine. See, now how to find out the run level? We talked about run levels, right? So run levels are like this. Depends on run level, some services will be started. So we have to set the default run level as any 1, 3 or 5. Like now, how to check that the default run level? So we have command run level. Run level. When you run level, it shows the run level number. Run level number. Basically, when you want to run commands in Linux on shell prompt, this basic syntax looks like this: command name, options, and arguments. Basic syntax. So command name, instead of command name, you can specify any command name. Option, every command comes with different options. We can pass arguments. So here arguments are nothing but file names or directory names. File or dir names. We can pass multiple arguments. So that is depends on, as per requirement, we can. So we can run command without options, without arguments. Some commands required options and arguments. Now here just we executed for to see the current run level information. Run level. The same command will work in 6 environment also. So RHEL6. In RHEL6, Oracle Enterprise Linux 6, any version, and CentOS and Fedora also. In Ubuntu also, same command. Any Linux flavor. So if you want to see a run level, just run run level command. It shows the run level number. So N means the previous run level. There is no previous run level. Current run level is 5. That means graphical user interface. Graphical user interface. So we have another command also, who space -r. Who space -r. So there is another command, who. So what is who command? We'll see later. When you use -r option with who, it shows run level, current run level name. Same command we can run here also. Right? So in 7, there is another command to see the default target. So here also known as targets, right? So for that, we have a systemctl command. So what is systemctl? We'll see. There is a concept about the service related commands. So using this systemctl, we can manage services. So what is services? We'll see in servers class. Systemctl get -default. When you run this, it shows a default target, graphical.target. In the sense, run level 5. Run level 5.target. Okay. So run level 5 or run level 5.target or graphical.target. Both are same. Or it shows here graphical.target. It means run level 5. But the command is not work at run level, RHEL6. Only the command will work in 7 environment. Either we can run in Ubuntu also, same. We have a Ubuntu operating system, right? Same command we can execute. Systemctl space get -default. It shows. No, only for 7 it modified. So because the process and some the layer structure is defined, implemented with new features. So for that, the name also renamed like systemd. Yeah. So 564. So it contains the same as it is the structure, booting process, kernel architecture, and the versions. Process information, everything. But there is a little bit changes in. Pardon? So, we will see that. I'll tell you that. Pardon? Yeah. What release version you installed? We can see that. We can see that. See, graphical.target. The same command, it won't work here. If you want to see the run level information in 6 and 5, the previous version, we have to use run level or space -r. Right? 6 vi/etc init tab. So this is the file is responsible for to set the default run level as 5 or 3 in 6 and 5, but the file is deprecated in 7. Okay, so we have to create a symlink for default.target file. Okay, I'll show you that. So in 6 we have to edit to set default run level as 3 or 5. Use editor name vi or vim, file path like /etc/init tab. Once you run, it shows id run level number init default. Just modify. If you want to use run level 3 as a default one, remove 3, save and reboot the machine. Automatically operating system will be started at run level 3. Right? Pardon? Yeah, we have to execute the command. So after saving this, here specified the default run level as 3 in file. Now we have an init command, yes, to switch to another run level. So when you pass signal 6 to init process will execute the scripts related to 6 run level. 6 means reboot. It will stop the process, I automatically will start the process. See, so rebooting. So if you want to shut down, init 0, init space 0. If you want to go to single user mode, init space 1. Pardon? Pardon? I didn't. Yeah, system administrator and server administrator. Users cannot not perform. Only a root can perform. That means administrator can perform. Normal users can't perform. So we can allow to perform normal users to administrative tasks. Yeah, if he allows to perform, we can. So we have a concept like sudoers. So when you add users into that sudoers list, then user can perform. So what tasks you allocated to perform? We can make one user as admin, like root, then user can perform these actions. See, we specified run level 3 as a default one. We get text user interface. So I'll tell you everything, okay, in the coming classes. Okay, so I'll compare with this latest version and previous version. Just note down that whatever the differences, I'll tell you in the class. Okay, see, now run. Enter username, password. So run level 3. I'll get non-GUI. If you want to modify again, we can modify. From here, etc init tab file. We have to edit. What is the editor? We will see. Okay, later. Just change the run level number 3 to 5. Now modified, right? Specified default run level as 5 in 6. Init 6. Again, the services will be started. You will get a graphical user interface. In 7 also, we can do the same thing, but here, so we have to run commands to set the default target. So we have a systemctl command to manage system services. Using that command, we have to set the default target as run level 3 or run level 5. I'll show you now. See, here also we have a init tab file. See, but what it shows in the first line, init tab is no longer used when using systemd service. So if you want to set the default target, so we have to execute this command. To set a default target, systemctl space set -default target name. Target names are like run level 0.target, run level 1.target, run level 2.target up to 6. Or we can use run level 3 as multi-user.target. For run level file, graphical.target we can use. Just run systemctl set-default graphical.target. Target will be created. Okay, got it? Say no. The default now current run level is graphical. That means run level file. Now run systemctl set-default. Or we can use multi-user dot target. I'm going to set the default target as 3, or we can use instead of multi-user run level 3 dot target. See, first removed existing symlink, automatically created. So basically your target files, the script files located under this directory /usr lib systemd /system. It contains all target names. That means run level script file location /usr /lib /systemd /system. See, automatically created symlinks to default target. By default, your systemd service will read this default target. So what it contains, the same service run level will be started, your operating system. So now reboot, what will happen, we'll see. We modified default target as run level 3. After rebooting the machine, operating system started at run level 3. So if you want to see that information, just log in as user. What it shows now, 3. So or run, we can systemctl get -default multi-user target. Got it? Like we can modify. We can set the default run levels. Okay. See, Monday we'll see the file system architecture, file system hierarchy, features of file system. Okay. So then we'll see the basic commands. So different types of files we have. So what are those? How to identify the files?